The physical universe is defined as all of space-time and their contents. Such contents comprise all of energy in its various forms, including electromagnetic radiation and matter, and therefore planets, moons, stars, galaxies, and the contents of intergalactic space. Our galaxy is just one of more than 170 billion galaxies in the observable universe. The universe is probably infinite and there is no end to it. Our solar system is part of the galaxy known as the Milky Way. It is about halfway out from the center. Our Sun is just one of the stars in the galaxy, one of between 100 and 400 billion stars. Our solar system goes around the center of the Milky Way once every 250 million Earth years. The Earth is part of our solar system in which center is the Sun. There is a short period of time in the early years of the universe when life is possible. This period, in the history of time, lasts just a second. A flash, a click of the fingers. The planet Earth is the only place in the universe where life is known to exist. It has all the conditions that are suitable for supporting life. Earth is result of some 4.5 billion years of cosmic construction and is abound with life thanks to an unpredictable set of conditions. When you start to look at all of the things that have come together in just suitable way to support all life, it gets a little bit mind-boggling. Our solar system is comfortably situated in a safe harbor between major spiral arms in Milky Way. To support life as we know, planet must have right place in its solar system and galaxy. Life will not emerge or survive for long near centers of galaxies. In these regions there are high density of stars that could explode at any time and expose any life to the planet's surface to deadly radiations. As our planet is located in periphery of Milky Way, so distribution in our galaxy of gas, stars and planetary systems make these conditions to act as protectable barriers for Earth's life. Scientific results indicate that for Milky Way and other similar spiral galaxies, the most dangerous regions are in the galactic center with densely located stars, whereas periphery spiral arms pose fewer hazards for existence of life. Evolution of our galaxy allowed to create habitable zone for Earth. Each of the planets in our solar system experiences its own unique weather. But one thing is certain, only Earth has weather we can live with. Earth has stable rotation. Regularity and frequency of day and night on planet with stable rotation go far to prevent extreme temperatures and encourage life. Our Sun is a stable and long-lasting star. Stars more massive than the Sun burn hotter and usually don't live long enough for planets to develop life. Less massive, younger stars are often unstable and are prone to blasting their planets with bursts of radiation. One another advantage in Earth's structure is its dynamics of the inner core. Earth's inner core is the innermost geologic layer of the planet Earth. It is a solid ball with a radius of about 1 to 120 kilometers, which is about 20% of Earth's radius. The interstellar cloud of gas and dust that gave rise to Earth contained enough radioactive elements to power a churning core for billions of years. This creates a magnetic field that protects the planet from dangers from space like radiation. Some research reveals that less than 10% of terrestrial planets may have a satellite large enough to provide the stability life needs to develop. There is rounded astronomical body that orbits the Earth as its only natural satellite called Moon. Scientific simulations show that Earth's moon is not only unique in the solar system, but may also be rare throughout the universe. The moon has been recognized as a significant stabilizer of Earth's orbital axis. Without it, scientists have predicted that Earth's tilt could vary as much as 85 degrees. In such a scenario, the Sun would swing from being directly over the equator to directly over the poles over the course of a few million years, a change which could result in dramatic climatic shifts. Such shifts have the potential to impact the development of life. Also, the moon causes the tides, and some researchers think that life began in tidal pools. In setting of dynamic geology, early Earth's history has also been scrutinized. It has been considered that the impact rate of comets and meteorites on the early Earth decreased to a relatively slow rate about 3.8 billions of years ago. As a result of these considerations, life could not have arisen on Earth before this harsh bombardment period ended, or life would have been wiped out by this dangerous space hazards. Whether the history of our planet is typical is still unknown, but its structure and global geophysical properties are the result of the whole architecture of the solar system and its sequence of formation. The Earth is the right size. If it was bigger, gravity would be much stronger, and we wouldn't be able to move. If it was smaller and gravity was weaker, it wouldn't hold our oceans on the planet. 70% of the planet Earth is covered in water. Presence of life on Earth depends on the availability of liquid water. In living systems, water is pervasive and ubiquitous. Because of its unique characteristics, it suggests that water has allowed the progressive transition of non-living to living matter. No other molecule, abundant on the primitive planet Earth and abundant in the solar system, could have played this role. Our atmosphere blocks harmful solar radiation, but allows enough heat from the sun to warm us. Earth's atmosphere consists of a number of layers that differ in properties such as composition, temperature, and pressure. The atmosphere acts to shape a planetary surface. Ancient plant-like organisms in the oceans added oxygen to the atmosphere and created a high-altitude layer of ozone that shielded early land species from lethal radiation. Ozone layer is a region of Earth's stratosphere that absorbs most of the sun's ultraviolet radiation. As ozone in the atmosphere prevents most energetic ultraviolet radiation reaching the surface of the Earth, it makes its surface habitable for life. We have seasons because Earth's axis, the imaginary line that goes through the Earth and around which the Earth spins, is tilted. It's tilted about 23.5 degrees relative to our plane of orbit around the Sun. As we orbit our Sun, our axis always points to the same fixed location in space. The axis is tilted and points to the North Star no matter where Earth is in its orbit. Because of this, the distribution of the Sun's rays changes. The fixed tilt means that, during our orbit around our Sun each year, different parts of Earth receive sunlight for different lengths of time. It also means that the angle at which sunlight strikes different parts of Earth's surface changes through the year. Sunlight striking the surface at an angle is spread across a wider area compared to sunlight striking perpendicular to Earth's surface. Areas that receive more scattered sunlight receive less energy from our Sun. All of these factors combine to give Earth its annual cycle of seasons. So the whole Earth's surface is warmed and cooled once a day, every day. If it didn't rotate, one side would be permanently hot, and the other cold. It is a perfect distance from the Sun. If it was closer, there would be too much radiation. The Earth would be too hot. Though it is strictly impossible to say conclusively that terrestrial life is unique and present only on our planet, there is probably an almost infinite number of planets in the universe. Life, however, prevailed on Earth. It seems that life was fully established on Earth by 3.5 billion years ago. The nature of the early planet on which life originated, flourished and diversified, is being reconstructed by scientists using geological and other evidence. It seems that almost all terrestrial environments, hot or cold, dry or wet, neutral, basic, or acidic, are inhabited. At the time of early Earth, chemistry turned into biology. Since the dawn of history, people have turned their eyes to the stars and wondered if there are others like themselves out there. Are we alone? Is really a loaded question. When humans pose it, they are generally not asking whether another world is crowded with bacterial analogs. The detection of life on another world is a real possibility. It can be even stranger that life might be common in the universe, but intelligence is likely rare. Earth has been around for the past 4.5 billion years or so, about the last third of the universe's history. All evidence show us that life arose on Earth very early on. It's very difficult to know what is the true probability of life arising on Earth. In order to know such a thing, we must create and evolve same conditions and environment that was present on Earth back in the time, over billions of years. Even then, we might not always get the same results. This is reasonably an expected approach to scientific question. This problem solving is a challenge, and in this case seems that the math is not enough. As the following wisdom says, if something is unlikely to happen and happens with 100% accuracy, then only its existence denies the possibility. This fact is like our existence, our possibility of existence in this world. So according to all the previously mentioned things that make the Earth unique in the all, our planet represents a miracle in the universe. The miracle that provides a home for is believed to be over 15 million different species, of which the human species make up the most advanced and intelligent perhaps in the entire universe. This miracle happens now. Thanks for watching this video. If you like, be sure to give thumbs up and subscribe to help this community grow.